Okay, good morning, everyone. Today is the last week. I'm the last class that I'm teaching. None of you were volunteered to present today, so we have some teachings and not too much because I know that this is your last week and you're ready for the exams. So uh, let's before going to the teaching part, let me give you a big picture. So in this course, we had three major sections: descriptive, which we had some hands-on experience using Tableau, and we focused on the visualization section. In the second section, it was predictive analytics, which we focus on using machine learning algorithm to predict some events. As I said, in some cases, uh, higher accuracy is not the ultimate goal. We want to look at the most important features. So it's the reason even in 1 week we focus on H2 components for finding the most important features. And the last section is prescriptive, which we use Excel solver and also Lingo to solve some prescriptive analytics. Basically, in the last section, you try to optimize your business or the situation that you are in. So we all know we are in the COVID era, so learning has some difficulties and you might have a harder learning curve. Me and other professors are aware of it, so no worries. We know that your learning might be affected and is suboptimal. So, but hopefully good days are coming, and especially in my class, we had so many in-class activities. Like you usually don't sit that much, even you stand up and like walk in the class. But so we had some limitations. Sorry for that. I mean, hopefully you learn enough, and I will be more than happy to see the outcomes of your final exam and the project that you're going to present. Okay, what is the next? You should be get recognized and get some advantage out of it. So I know that many of you are looking for um, internship or jobs. It's better to get a certificate, especially from Tableau. I put an exam guide for the Tableau certificate link here, and also over your Moodle. If you go to the week 14, I put some links or some information about the videos that you can learn for free. So let me just open Moodle here. Okay, it's the Moodle. Go to week 14, the materials section, and this PDF file. So if you see, it has some subjects for your exam. If you're interested to get Tableau certificate, let me see if we can zoom in. For example, I mean, like data blending or joint type with union, managing metadata. So if you go to Tableau, there is free video clips for that and free learnings. Also, if you take this link that I put here for Tableau, tableau.com and learning, they are either here or you search for them. So let me search for one. So I told you guys to, like, let's say managing metadata. I come here, paste here. And in the learning section, this is a video about how manage metadata in.
Welcome to this video.
Let me stop it. So in Tableau, having said that, you can just use those information and in your spare time, or don't waste your summer. So you can learn some extra thing from Tableau review. There are also, you might find some sample problems if you Google it and basically use those materials to get ready for the Tableau certificate. You can share it on your resume or LinkedIn. So people, so many recruiters have some softwares. They search through your LinkedIn profiles or the PDF files that, or like whatever files that you submit for the job application. So you don't want to be filtered out if you don't mention anything about Tableau or other useful softwares. But what are the other alternatives? Your Clark University students, if you go to LinkedIn Learning and just log in using your Clark information, you can get some free courses through LinkedIn, and then you can post the certificates over your LinkedIn account. So recruiters can read and basically they can pick you as a suitable one for the position. So I highly recommend to use for the more specifically Tableau, but in case you have some issues and maybe you're more looking for free certificate, uh, LinkedIn Learning is a good one, which is like free for Clark students. Like as example, I went there, I filter out courses here, as you see. And as you see, there's several courses. You can pick the one that is more suitable for you and just post this certificate over your LinkedIn or resume. So hopefully would be a good case for any job position or applications. On top of LinkedIn, which is free for you, there's Udemy, Coursera, edX, Datacam, and other platforms. All are fine. More specifically, just see if is possible for you to post your certificate over your LinkedIn profile. Okay, over the course of the summer, or if in case you have free time, Power BI, Python, or Hadoop and Spark are really good skills for someone who want to focus more in the analytics part. So, our time was limited, and also we should focus on most relevant tools. Anyway, from these five, I think Power BI should be in your tool set. Python R is also good. Hadoop and Spark are the high-end tools that you can learn. It just means you're very smart and up-to-date person if you have skills of Hadoop and PySpark. So instead of using Netflix, you should use learning platforms. I don't want to look too much nerdy, but I just continued my Netflix, but I didn't have time to watch a series over Netflix. I graduated after long academic educations, but I still try to learn every day. And I'm just saying not for, I mean, learning is not just for getting a job or like getting a certificate or degree. You can make your own business. If you study the people's life, I just watched like Instagram founder. He's a billionaire right now. So that guy just kept learning every day, even after graduation. So every day he tried to study new skills and tools, and then he invented Netflix and a billionaire. And I have some friends actually, frankly speaking, they are daily trader in the like Bitcoin or like cryptocurrency or stock market. They learn every day. So because that's a high risky job, and you can do random things in those markets. Sometimes you gain, but it's better to have skills so you have less mistakes and makes more money. I'm not sure if you're allowed to, for the international student, I'm not sure if you are allowed to do such a things in the US, but most likely at your home, you are able and legally can do those trades. Having said that, we know the situation this semester. Even we couldn't deliver the best teaching that we usually do. So our expectation is a little low. I mean, and probably most of your professors are much nicer in gradings, so no worries. And I just lift all the due dates, so there's no solid due date or hard due date. Just don't submit anything after May 28th because I need to grade them. And I think some of your assignments are left, so we start to you start to see your grades from today. And but I strongly recommend to focus on your last assignment and help each other because that was the last year final exam. So by reviewing that final exam, hopefully the last part of your course, which is the exam, should be easy for you, because if you are this one of the most difficult type of questions, I mean the next question shouldn't be that much difficult. Any questions so far?
Hi, Professor.
Sure.
Would you mind to give us some hint for homework 9 question 2, the stock predicting model?
Some hints.
Yeah, since there are so much variables there, I'm not sure which variable should I set as target variable.
Okay, so target variable, I think that's Simon. You have some flexibility, frankly speaking, but one of the targets that you can have is like price movement. So price movement from the previous day. So what can you do? You have the price day for every day. You can add a new column and just see if comparing the previous day, is there any increase or decrease? So maybe if it's increased, just you can plug 1, otherwise 0. Or you can do like continuous prediction, just instead of looking at the price movement, focus on the just price. You might have so many variables and you might basically make some variables out of them. So if you think there is too many variables, maybe you can do feature selection, as we had a class for H2O. That's an easy one. So you can use H2O to limit your features, and the remaining is just like previous assignments.
Okay, thank you.
You're welcome. Okay. I think if you do price movement, probably it's an easy assignment or question, because I think even over Excel, you can just compare if it's increase or decrease. So you can just put the if command in the Excel file and find it again if it's increased or positive, 1, otherwise 0. So anyway, you have some flexibility. Okay, so there is some time left. I wished you presented, but it seems there's not that much people who wants to volunteer. So let's look at the previous week. We had something left over from the previous week. If you go to model and week 13 and class materials, let me just show from my screen. So okay, go and take Maxflow, either both Excel file and Word document. Please download on your system. And I just wait a couple of minutes for you, then we start from there. I think some of your friends are in HR based on the first assignment that they have from there. So you can reach them, ask them which certificates are good for the job market. I think they can give you very good insights. Okay, so if you might remember last week, we look over this transportation problem. So I just simplified here because sometimes having like multiple paragraph is kind of more difficult to see. But in point 1 and 2, we have 100 units of a product. So minus 100, minus 100, anyway, minus sign just means we are sending out from them. So their production points or supply points. In point 3 and 4, we have plus 75, plus 80. It just means their demand points because they have inflow. So on each arc or link, we have UB means upper bound, means the capacity of that link, and also transportation cost, $5 per unit. And we have for all of them. Like, for example, again, from point 2 to 4, 2 is a supply point, 4 is a demand point. So the cost of unit of products to be shipped is $3 with upper bound of 35. Okay, having said that, look at the inflow of point 3 and 4. So what is the inflow? How much at max I can provide in these 2 points? So if you just sum up all of the links, like 35 from 2 to 4, 35 from 1 to 4, 30 from point 2 to 3, and 40 from point 1 to 3. If you sum them up, the total inflow based on the capacity of the links is 140, 35 plus 35 plus 30 plus 40. But if you sum up the demand is 155. So your demand is much more than what can you deliver. So if you make a constraint, so let me go over the problem. So usually in the transportation nodes, we want to fulfill our demands. So if you look at the here, look at J11 to M11. I said greater equal J12 to M12. So for the supply points, you should send less. For demand, we want to send less, same or more. But it's not possible if it's an impossible constraint due to the link capacity. The remaining part are same. So we have some blue cells. It just means there are decision variables indicating how much you've sent from 1 to 3, 1 to 4, and up to like 2 to 4. And also you have link capacity here, 40, 35, 30, and 35, 40, 35, 30, and 35. So the blue one, which is how much you decide, because there are decision variables, times the capacity, would be objective function here. So, sorry, I made a mistake. So decision variable are the blue ones, and it depends, they should be less than capacity. That makes sense a lot. And also cost would be how much you send, I mean, through the decision variable times cost. So here in G15, you see that my decision variable is just some product of decision variable times the unit cost. Okay, let's look at solver. So we have our objective function G15, some product of a decision variable times cost. We want to minimize. Usually in transportation problems, we try to minimize. My decision variables or changing variables, whatever, is F7 to F10, because it just means how much I want to send to each node. If you look at the first constraint here, F7 to F10 less than H7 to H10. This just means the decision variables, which is the usage of each link, should be less than capacity. And the last constraint, or second one, just means we want to send less than demand support points and at least more equal demand. You already saw that problem is not possible because you cannot fulfill this demand, but you have a constraint saying that you should at least provide that demand. So mathematically, it's impossible. Any questions so far? Why is it clear for you why this problem is not possible?
Professor, I have another question.
Sure.
I do not understand the -1 and the -1 part on the J column, the J, K, L, and M. Could you explain that?
Actually, this is nothing, just saying that these are supply point. We want to send it out. But there is another reason, just to make the formulation easier. So look at this, my second constraint. I said J11 to M11. These yellow ones, greater than or equal J12 to M12. So look at, Ashisha, look at minus ones. What numbers could I put in the yellow cell? For J11, could I put -80?
Yes, you can.
Yeah, it's less than what can I send, because I can't add that. Can I put -110?
No, you can't.
So look at L11 and L12. I said I want to send more or equal. So can I put 60 there?
Yes.
No, I have a constraint saying that I should send more.
Equal. Okay.
Okay.
Yeah.
So, and it's my policy for demand. I want to at least provide to the demand level. Mathematically, I can put 90 here. Maybe you would blame me, say, Hamid, you want to minimize the cost. But if you put 90 there, you are wasting some. That's correct. But mathematically, it could happen because my constraint is saying that for those demand points, I should at least provide 75 and 80. So as you see, with current formulation or current shape, I can just follow my policy of demand and supply, right? This is correct. Does it sound correct for you so far?
Yes, it does. Yes.
Okay. But you might say, what's the point of putting minus? Maybe I could put plus, and that's correct. You are completely right. So for doing that, I have to put 100 and 100 here. But for the solver one, I should modify it. So I should add another line. Let me just see if I can change it. So instead of, no, it's not this one, it's the second one. So instead of J11 to N11, I should change it to M. Oh, here too. So this is for my demand, and also I should add one more, less or equal these two. So instead of adding two lines of the codes, I just made one. Now it looks positive, looks better to you, right?
Yes, it does. Yeah.
Yeah.
Makes
So
sense.
if it makes more sense, you can do that.
Okay. Thank you, Professor.
You're welcome. So let me just open it again because I want to be same for all of your friends. But actually, that was a really good question. Thanks for asking. Okay, anyway, so let's go back to the previous form. And actually, please solve it through the new format. If you couldn't get the same answer, reach me later, maybe we can have a discussion for that. Okay. Okay, cool. So, okay, so as I said, this minus is just for formation and just makes a little easier in terms of the number of constraints. Anyway, so we have seen following the policy of providing at least equal to demand is not possible because we have some limit constraint. So let's just solve it. We already know there is no solution for that. If you do that, you see solver could not find a feasible solution. That's right. There is no feasible solution. Let's see what can we do. If you click on, I'm not sure, see if you see my monitor here. So look at, click on problem 2.2. So it's actually the same problem, but we try to be kind of innovative. First of all, we want to first this problem to provide as much as demand or deliver as much as the demand what we have, as much as possible for demand. So for doing that, we want to send out as much as products that we can. Also, I mean, so the goal is sending out as much as possible, given the fact that we have those constraints. So look what happened. We added dummy points. It's just an imaginary point. And we are saying that I put the upper bound is 100 with the 999 is the cost. So you might ask, what's the point of 100 and 999? These are just large numbers. So I cannot put like saying that very expensive point and also very large capacity. These are in English alphabet. So for the computer, I just should provide some numbers. So having said that, I just put 109.99 as a very large number. Look at the formulation. Now I have two links, one to dummy and two to dummy. Decision variables for those points. As you see, there's a high cost and high capacity. Also here, we added the dummy point, and you see 1 to dummy. So 1, 2 to dummy, there is a 1 here too. For the constraint, still we have same. So F7 to F12, less than capacity, H7 to H12. Also J13 to N13, less or equal these points. Just look at the differences right now. Let me go back to previous problem. We said the yellow ones, J11 to M11, greater or equal J12 to M12, which was not feasible anyway, because we wanted to send less than supply and more than demand. Now, look at the solver and equation. The yellow one now is less than the white one. The yellow cells are less than this. Because we want to make it feasible. We know that we cannot send greater or equal the demand, as also is possible to send less than supply. Okay, let's press solve. Okay, look, for 3 and 4, we didn't provide 80 and 75. We provided less because we had some link capacity, but we just forced the supply point to send as much as they can. You might ask me what the constraint here, saying that J13 up to N13 less than J14 to N14. So for J and K, for these two supply point, why it's not 150 and 120? The constraint is saying that we want to send more. Sorry, we said we want to send less, they are negative. So the absolute value should be more, like minus 120 or minus 150. Since we have a minimization problem, the solver or the internal algorithm try to minimize it so they don't send more than that. They didn't send more than 100. And if you look at the these two decision variables, as you see, 25 and 35 to the dummy points, but we know that this is an imaginary point. We just try to make a trick to fool Excel solver. So Excel tried to make it as minimum as possible, but it couldn't happen. you don't have to send anything. You can just exclude them, and this first four could be your just transportation plan. So anyway, the big picture was in the first problem, it's not possible to provide demand because of some limitations. So we try to fool Excel. We add a dummy variable and we force it to send as much as possible through the constraints of supply point and demand points. And on top of that, we did it minimization. So this, I mean, the outflow couldn't pass the capacity. Any questions so far? I think the best way of learning, just try to think about the policy, why we add that dummy points. And I mean, it's not very intuitive, I know, because it's sometimes in operation research or prescriptive analytics in general, you need to have some innovative ways. It's one way that we could just solve this problem. The overall picture is with this problem, try to be feasible. We didn't have infeasible constraints. Besides, the overall policy to just send out as much as possible and trying to minimize the cost too. As you see right now, the outflow of supply is 200. This was maximum possible. And although it was maximum possible, it tried to avoid the dummy variable because sending there is too expensive. And our objective function is minimization. For this reason, the maximum possible outflow to those demand points happened. As you see in prescriptive analytics, there's not that much of math in it. It's mostly logic. Do you need me to explain these minus plus points here?
Yes, please.
Okay. Okay, so I think I explained in previous videos, these are like just transportation problems, how do we formulate it? So just look at this minus, minus, minus. Point 1 is a supply point, just sending out. How? 1 to 3, 1 to 3, 1 to 4, and 1 to dummy. So 1 to 3 and the information. So cost is 5, capacity is 40, and the coefficient is minus 1 because we're just sending out. 1 to 4, cost is 6, capacity is 35, and coefficient is minus 1, just means outflow. And same for 1 to dummy, cost is infinite or like a very large number, but again in computer I cannot just type large number, I should put a actual large number. Capacity of 100 and coefficient is minus 1. Same for point 2 because it has just outflows. But look at point 3. For point 3, you have inflow from 1 to 3 and 2 to 3. So 1 to 3, now the coefficient is 1, 2 to 3 coefficient 1, and the remaining are 0. And same for point 4 and point dummy. So based on what your decision variables, which are in these blue cells, you can understand how much you're sending out or in. Let's point 1. Minus 1 means coefficient, means outflow. 0.40 times 40 minus 40. minus 1 outflow times 35 minus 35. So 40 plus minus 40 plus minus 35 minus 75. Also, there's another outflow from 1 to dummy with the coefficient of minus 1. So times 25 minus 25. So minus 1 times 40 minus 1 times 35 minus 1 times 25. Summation in this blue cell, as you see, is exactly equal to capacity. Let's look at point 4. So for point 4, we have inflow, because the coefficient of 1 means this inflow from point 40. Decision variable is 35, so 35 times 1 plus 1 times 35, so it would be 70. So, and the other links has a coefficient of 0 because, for example, for point 4, we don't have anything from point 3. We just have 4, and anyway, this just doesn't make sense because 1 to 3 doesn't have any association with point 4. So here should be 0. But instead of putting 0, just leave it empty, because and then I multiply the column of M, which is for point 4, to the decision variables. For the decision variables that are not relevant to 4 would be considered as 0. But you can easily set it up in Lingo. Let's see, let's see how much time we left. If we didn't have enough time, maybe I do it by Lingo and post it later. The overall logic is we should make a table of in Excel that talk about the logic which is behind this problem. So the logic behind of this problem is we have some outflows, we have some inflows, cost, capacity, and there is some association between the overall cost and decision variables, which is minimizing the cost. So we know the cost is decision variable times unit cost. The actual cost is not this because you should exclude the last 2 points. But for fooling Excel, I include it here. Actual cost is just summation of, or let me just copy the formula from here. Six, 635. The upper number cell just for fooling Excel, because we know that we don't want to send anything to the dummy. It's an imaginary point. The actual cost was 635. Any other questions about this problem? If you are just try to look over the logic by yourself, later if there's issues, just please reach me through office hours so I can go with you. Go to the problem again. Okay, let's look at the last problem of this course. By the way, I posted another type of problem, which is shortest path for the week 14. It's just for extra reading, and I won't ask them in your final exam. I was thinking that's good, could be another good applications of prescriptive analytics. That's for finding shortest path between 2 points. But in case you're interested, please look over the materials that I post for week 14. Okay, in this question, you don't have the network, but you can build it by yourself because you have link information. For example, from L1 to L2, the cost is 12, capacity 8, same for other links. So draw a diagram. Flow of the cars containing a t-shirt is given. Flow of cars containing t-shirt is given. 15 cars are supplied from L1 and L5, sorry. And sorry, a minute. 50 cars are supplied from L1 and 50 cars from L2. So we have two supply points of L1 and L2. At L5, 10 cars are required. 10 cars are required at L4. 20 cars are required. So there's two demand points of L5 and L4. In L5, the demand is 10 and L4 is 20. Create a flow model with lowest cost, unit cost, and capacity of each road is given. Make sure the model converges. So the model converges just means we have a feasible solution. So another way of saying that we are looking at feasible solutions, saying that model converges. I'll give you like a few minutes to think about that. Then I go to over the solution. Okay, let's draw the problem. So using this table, I draw the network. So for example, from L1 to L2, unit cost is 12. Also capacity is 8. Same for other links like L5 to L4. L5 to L4, $12 cost. Capacity is 8. Okay. So we try to solve it through conventional or like ordinary transportation problem. So we want to send less than supply capacity, and we want to follow the links limits. Also, we want to fulfill the demands, which we should send at least equal demand. In comparison with the previous problem here, we can easily see that it's not feasible. But for this one, it's not possible. So if you just sum up the links and look at the demand and capacity, it seems it could be feasible. So it's not there's no obvious sign of infeasibility. But let's just solve it. So we have some decision variable, unit cost. So at the end, objective function is just multiplication of decision variable to the unit cost. We have capacity. So in the solver, we have a constraint for capacity. So E7, E14, decision variable is less than G7, G14. Also, look at the next constraint, H15 to L15. Greater equal H16 to L16. It just like because L15 more than H16 to L16. For H15, which is the first yellow cell and second yellow cells, whatever you send, their summation would be like -14, -13, because we have a constraint saying that that summation should be greater than -15 and -15, so it should be less negative. And for the demand points, we provide more, so at least 20, at least 10. Again, you might say, why might we send 22 or 15? Since we already said this is a minimization function, it try not to send more than what we demand for. And we cannot see any sign of infeasibility, since by rule of thumb, it could possible that this we can find the actual solution. Okay, by the way, I forgot L3. So L3 doesn't have any demand or supply, so the summation of in and out is 0. It's the reason both are 0 here. It's could be just a temporary point or maybe temporary warehouse. Anyway, inflow and outflow is 0. So, and if also we said, if you look at the constraint in the solver, we said greater than equal. So the yellow cell could be 0 at the end because 0 is greater than or equal 0. Let's just solve it. Infeasible. And here we just have 5 points. It's very hard for us to see if it's feasible or not. Let's say we have 100 points or more than that. In all those cases, when you just keep adding more points, finding, understanding if there is a feasible solution, just getting harder and harder. But just look at the big picture. The big picture is you want to send as much as you can. You want to send out as much as possible. So what if we just add the new dummy points? So if you, again, we add the dummy points here and just changing the constraint. So here we said H15 to L15 greater than equal the next line. So here we would say H15, so H17 or yellow, anyway, yellow cells are less or equal the next white cell. So with less than equal, you can send basically you try to you let it to have less than what you need for the demand points, and it just lets some products go to the dummy. But since at the end we want to minimize the cost, we know that the algorithm tries to minimize amount that it sent through dummy points. So if you minimize the left side, I mean sending from supply point to the dummy, the right side, which is sending out to the supply point, would maximize. So you send as much as you could. Again, you might ask a question, what, maybe H17 and I17, they could be -17, -18, or 19, because in this second style, when you have dummy points, you said the yellow line is less than the next white one line. I mean, mathematically, in these two cells, you could have -17, -18, But since we try to minimize the cost, Excel solver try to make it at least, they try to make them equal 15 and equal, I mean, minus 15 and minus 15 to minimize the cost. Otherwise, the cost won't be minimized. Any questions about this problem? Again, if you, I think maybe you need to just do some thinking by yourself. These kind of problems usually needs your personal thinking. You know, it's not like, because it's more related logic, it's kind of philosophy. So it's very hard to inject to somebody's brain. So they should digest by themselves, maybe think loudly inside and think what if those constraints and relationship make sense. Okay, we add one dummy points, we need to update the table. So here we add the links. Also, we add the dummy points here. Again, the other differences is just changing the direction of the constraint. Now we don't say the yellow cell greater than equal the next white cell. We just say it's less or equal. Having less or equal, mathematically here it could be minus 17, minus 18. Intuitively, it doesn't make sense because, I mean, the supply is just 15, but we force Excel to just keep it as minus 15 and minus 15 because we want to maximize the outflows, and we don't just want to maximize it, also want to send to the demand points, L5 and L4. So this is the trick that we use. Let's solve it. Okay, so just before that, just look at the big picture. The big picture, we just want to send everything out, and everything out, but we want to force Excel solver to just send as much as possible to the demand points. What can we do? It's just having a dummy points, very expensive dummy points that Excel solver should avoid from that point. Otherwise, we should have a very expensive cost, which is not suitable for this kind of problem. Okay, I stopped like 2 or 3 minutes you to think about this problem because it might be a little challenging. Then I'll go forward. Again, at this point, I just want you get the over the big picture and what is the trick that we try to use. We try to fool Excel. Okay, is there anyone now? I mean, I don't want you to just have a good grasp. It's okay if you don't have good grasp on the math part or the constraint parts there. Is there anyone can give me a big picture of what happened here or what we are going to do? Any volunteer. So it was, if you know there's no volunteer, I think it's a difficult question that should be in the final exam. Okay, give me a good hint for the final exam kind of question that I should pick. So, I mean, the big picture here, we cannot satisfy demand. We try to solve it through conventional transportation plan. It didn't happen. So what we did, we tried to fool. We tried to, first of all, send everything out from L1 and L2, but we wanted to direct those maximum outflow to the demand points to send just as much as possible. It was the big picture. Anyway, I think you probably, your brain is, your mind is preoccupied for so many things for the last week. Any questions?
Hi, Professor. I have a question.
Sure.
So this is more like on the application side. Practically, it is not possible to like enter all these tables, like when it comes to multiple constraints and maybe hundreds of data points. So, like, is there any other like open source software or application that is useful for this, like other than Excel, to go through the problems, like maybe to solve these issues?
Yeah, actually for this problem, you can, I mean, Excel is not too bad. Actually, you can have, let's say here we have 5 points. I think even if it could be 1,000 points, it's still you can use Excel. In terms of formulation, we had Lingo before. So for some of you, Lingo might be much easier. So if you can just look over those videos that I explain about Lingo. In case there is others more professional tools when you have so much constraint and use other algorithms. Here we just use simplex, but you might use some other more advanced prescriptive algorithms. C++, MATLAB, Groovy, these are they have good like packages or libraries for more industry scale problems.
Okay, got it. Yeah.
Okay. Prescriptive analytics has so many other applications. If you end up working the supply chain management, companies they have large chains, supply chain, Amazon, transportation companies, Uber, all of them have a lot of thing, a lot of issues about business related to transportation. USPS, there are so many things. It depends. I think if you want to go further in those kind of industries, maybe you need to take more courses in operation research, so you get familiar for more applications or more type of problems. Cool. Any other questions? One of my friends, she was really good in prescription. I think she's working Uber right now. They are trying to find the shortest path, which is the topic that I put as extra for you to study, and is in the book for week 14. It won't be in the exam. Maximum flow, shortest path, these are very common problems in industry. People are just facing almost every day.
Yeah, so I have asked because like there is a challenge, ongoing challenge by Amazon about last mile delivery. So they are more interested in optimization of the routes. So I just wanted to like apply it and then I'll try and check it.
I didn't look at the challenge, but I think usually MATLAB is enough if it's like education of kind of competition. It's pretty much similar to Lingo. So if you look at Lingo's, I mean, formulating through MATLAB is not difficult. Similar to Lingo, it's just like the way that you write it in a piece of paper, you can just type it in the MATLAB and you get the answer. I haven't checked with the university, but also there is a open source or community version of a software similar to MATLAB. I can think what this was. So Kirti, I would send it to the link of that software because this like something like open source kind of MATLAB. Is not MATLAB, I forgot the name, but there's a lot of similarity. You can use, probably you can use that software. But if it's a kind of challenge, I recommend to team up with some industrial engineers. So you can just share your knowledge together and hopefully win the competition.
Yes, thank you, Professor.
Okay. Anyway, that was for today. I was really pleased with you. Yeah, I mean, you're a really good group of students, and no worries. I know some parts might be a little more challenging. Usually, this is the course people get good grades. So, but you see so many type of problems from visualization. Then we went to predictive part, then prescriptive. So. For your job market, I strongly recommend to get a certificate for Tableau. If you get it from tableau.com, is better. Otherwise, you are free. You can get free certificates from LinkedIn Learning, just attached to your resume or like more specifically LinkedIn. I have some students last year, they easily got a job, but just being good in this course. So, and you have a good summers coming up. Just instead of watching Netflix, which frankly speaking, I discontinued my Netflix. That's a really good app, and I love Netflix, but I love my time and my future more. So I have to discontinue. So, I mean, every year, I'm sorry, every day spend 1 or 2 hours for yourself. Maybe 2 hours, one hour maybe for going to the gym and doing some workout, 1 more hour for your brain and learning new thing. I'm pretty sure if you spend good amount of time in this course and just keep you updated, more specifically, if you make yourself very good at Tableau, Power BI, and Python, these are the trinity of this course. Most likely and most probably you easily get a good job somewhere. Okay, thank you very much. It was good semester. Hopefully next day of the week is for presentation. I don't teach, I just come to the class, see who wants to present. If there's no one, maybe, I mean, I just say hello and that's it. I also keep post some optional videos to watch because I'm not sure if next class how many of you wants to present. In case there's no one, I mean, no teaching, but I post some videos, and we have some guest speakers for analytics this week. I check their information. Maybe I put, if you attend those sessions, I give you some bonus points. Let me look at the information in case if I see they are useful, I send it to you. Even if I don't consider bonus point, good lectures. My colleagues try hard to invite people. So you can listen to them. I think all, or at least most of them, are Clark alumni. So they used to be a student like you, and now they have a job from their degree. So maybe you can get a feedback about what can you do. Anyway, thank you very much and have a great rest of the week.
Thank you, Professor.
Thank you.
Thank you.
Thank you, Professor.
Thank you.